Hello students, this is Ingrain. Welcome to our channel and welcome to the new video. Today we will start the language of chemistry of class 9. In this chapter, you are expected to learn the concept of symbol, valency, radicals, chemical formula, chemical equations, relative atomic mass, and relative molecular mass. These are the 5 broad topics that you must study from this chapter. In today's lesson, we will understand the concept of symbol, valency, and radicals. What is a language? It's a system of communication that uses symbolism. It's a medium of communication by which one person can share his or her thoughts with another person. In fact, in the field of chemistry as well, there is always a requirement of a common language by which the chemists can communicate among themselves. In earlier days, different alchemists used to denote the same elements with different symbols. This created a lot of confusion. Then Dalton brought up his own system of symbolism, which had its own set of pros and cons. But the cons always dominated the pros. Hence, this system was also abolished. Then a Swedish chemist, Johannes Jacob Berzelius, introduced the system of using letters as symbols for elements. The present system that we are using today was introduced by Berzelius. So, a symbol can be defined as the short representation for the full name of an element. Here is a chart showing various elements along with their symbols. The symbol derivation was based on certain rules. To understand those rules, let's take an example of carbon, whose symbol is C. This is rule 1, which said that the symbol was the first alphabet of the element name. So as carbon starts with capital C, the symbol of carbon is C. But what about other elements which also start with C? Well, in that case, rule 2 came up, which said that along with the first letter, a second prominent letter would be required for the symbol. And in that case, the first letter would be written in capital and that second prominent letter would be written in small letters. So, in cadmium, the symbol is Cd. In calcium, the symbol is Ca. Also, in certain cases, on multiple conflicts, symbols were derived from their Latin or German names. For example, potassium, whose symbol is capital K, was derived from its Latin name Kalium. Also, sodium, whose symbol is Na, was derived from its Latin name natrium. After understanding the concept of symbol, let us proceed to valency. Valency is basically the combining capacity of an element. In our junior classes, you must have studied that all elements have a certain set of electrons which are arranged in particular orbits. And that arrangement of electrons in orbits was termed as electronic configuration, which was based on a particular rule. The details of that rule we will discuss in our upcoming videos. So don't forget to hit the subscribe button and click the bell icon to get all the latest updates. Here, sodium has the electronic configuration of 2, 8 and 1. That means in the first shell, it will have 2 electrons. In the second shell, there are 8 electrons. And in the last shell, which is called the valence shell, will have 1 electron. And that electron present in the valence shell was termed as valence electron. And that possessed maximum energy. When valence electrons of one atom comes close to other valence electrons of another atom, they generally tend to get transferred or shared with other atoms, resulting in a chemical change. Hence, a valency can be defined as the number of electrons gained, lost or shared by it with other atoms during a chemical change. Generally, the valency of all metals and hydrogen is considered positive, whereas the valency of all non-metals or group of non-metals is considered negative. Let us understand this in detail. Valency of a metal is the number of electrons lost per atom of the metal. Like potassium, which is a metal, when loses one electron, it forms K1 plus. Magnesium losing 2 electrons will form Mg2 plus. And aluminium losing 3 electrons will form Al3 plus. Similarly, valency of a non-metal is the number of electrons gained per atom of the non-metal. In that case, chlorine gaining 1 electron will form Cl1 minus. Sulfur, when gaining 2 electrons, it forms S2 minus. And nitrogen gaining 3 electrons forms N3 minus. As electrons are considered to be the negative charge, so when the negative charge is lost, it is gaining a positive part. It's becoming positive. Whereas here, when number of electrons are gained, that means when negative charges are gained, it becomes overall negative. Also, we learned that elements having valency 1, 2 and 3 are termed as monovalent, divalent and trivalent elements respectively, irrespective of their charges. But what about the valence elements containing the valency 4? Well, they are called tetravalent, and the 4 valence electrons are there for covalent chemical bonding. Details of this topic we will study in some next chapter, so don't forget to hit the subscribe button and click the bell icon to get all the latest updates. Some elements exhibits more than one valency, and these elements are said to possess variable valency. The reason behind this is basically loss of extra electrons from the penultimate shell along with the valence electrons. If you see this figure, the last shell is the valence shell and the shell just before the valence shell is the penultimate shell. When electrons are lost from this penultimate shell along with the electrons from the valence shell, it gives a rise to variable valency. For example, Fe2 plus and Fe3 plus. What does this mean? It means when iron atom loses 2 electrons, it forms Fe2 plus, and when iron atom loses 3 electrons, it forms Fe3 plus. Here are a list of some common elements showing variable valency. You can see copper possesses variable valency of 1 and 2. Silver possesses variable valency also 1 and 2. Similarly, tin has variable valency of 2 and 4. While naming these elements possessing variable valency, a general rule is followed. The suffix for lower valency is us, OUS, whereas the suffix for higher valency is IC, IC. Following this rule, the copper with variable valency of 1 is termed as or named as cuprous, and copper with higher valency, that is 2, it is named as cupric. Similarly, silver when possessing the lower valency, it's termed as argentus, and with the higher valency, it is termed as argentic. Mercury with lower valency, it's called mercurous, and higher valency, it is mercuric. So now we can understand that all elements, be it metal or a non-metal, possess valency, or in some cases variable valency. When these elements combine in fixed proportions, they give rise to compounds. And most compounds are made up of two oppositely charged parts called radicals. The positive part is called the electropositive radical and the negative part is the electronegative radical. Let us take an example of potassium chloride. In potassium chloride, K plus is the positive part and Cl minus is the negative part. So, this positive part is the electropositive radical and this negative part is the electronegative radical. Generally, radicals are categorized into simple radical which contains only one atom like K plus and Cl minus which we have already discussed, and the other category is compound radical which contains atoms of more than one element like NH4 1 plus or NO3 1 minus. Hence, radical can be defined as an atom or a group of atoms which carries positive or negative charge and that behaves as a single unit in chemical reaction. As you can see in this example, nitrogen is bonded with 4 hydrogen atoms carrying a positive charge. And in most of the reaction that we observe, ammonium ion acts as a single entity. Hence, ammonium ion is an example of compound radical. Here is a list of other compound radicals that we commonly observe, which you can follow for your reference. This is a chart of most commonly used electropositive radicals and electronegative radicals. It shows the relevance of symbol along with the valencies. You can also understand that which are the simple radical or the compound radical. Moreover, you get to know that electropositive radicals are also called cations or basic radical and electronegative radicals are called anions or acid radical. Without this basic skill of valency, you cannot proceed with any of the topics of chemistry. So this is very, very important. As we have already learned that valence is the combining capacity of an element and it is used to write the chemical formula, that is, it tells us how many atoms of each element are present in a molecule, which makes you realize how important this topic is. It helps us to determine the chemical formula of a compound, which is our next topic. So students, do prepare this chart thoroughly so that you can understand our next lesson. But remember, this chart is for reference only. You must get the detailed list from your textbooks. Hoping that today's elementals are embedded, you are encouraged to take the self-check assessment. This segment is specially designed to test your understanding of today's lesson. Define the term radical. Name any two elements whose symbol is derived from their Latin names. Identify the monovalent, divalent and trivalent radicals from the list. Here you have to just identify the monovalent, divalent and trivalent radicals. Name the elements represented by the following symbols. The solutions of this set will be discussed as we complete the entire chapter. You can post your queries or doubts in the comment section and you may also reach us in the email ID given in the description box. Till then, take care and study hard. Meet you in the next video.